All right, so we're going to keep talking about ratios, but we're going to talk about ratios in similar polygons or similar shapes, but polygons is more appropriate. So ratios in similar polygons. And before we do anything with ratios, I want to make sure that you understand what the word similar means. The symbol for similar is this little squiggly line, like this. Now, you have probably seen that little squiggly line on top of an equal sign, right? And when you see that, that means congruent, right? But what you probably don't think about when you know that congruent is same size, same shape, well, the same size part is the equal part. So this is the size. The same shape part of congruent is this part. So this is about shapes. So just a little bit of information for you. If two things are equal, well, that means they have same size, right? They don't have to have the same shape, do they? So just the same size. And if two things are similar, well, that means who knows about their size, but they have the same shape. So that's just a little bit of math symbol history for you. One thing that you do want to keep in mind is similar does not mean same shape, like this is a triangle and this is a triangle. Okay, these are not similar shapes. They're not the same shape at all. Their angles are all different. Okay, so just keep that in mind. And another thing that we probably should add in here when we're saying similar, it doesn't mean same size, but it does have to be proportional size. And that's what we're going to work with today. That's what you're going to see a lot of. So I'm going to start out with a rectangle. I just like rectangles. They seem to work well for everything we do. And then I'm going to take, now and duplicate this rectangle, so I'm going to have another one exactly like it. I'm going to shrink it down. So it's still the same rectangle, I just shrunk it. Okay. And let's say that this rectangle's side length is 4 and this is 8. And then this rectangle is 3 and this side is 6. And we're going to go ahead and label our rectangle. So we'll have, this will be A, B, C, D, and then E, F, G, H. And the way we talk about these two rectangles is we'd say that this is rectangle ABCD, and this is rectangle EFGH. And if we're comparing them here, you might want to say that they're similar. They're obviously not congruent, but they are similar, and that's that proportional size. Well, the way we check that is we look at the corresponding parts. So we look at AB, which is this side over here, and we're going to compare it. And how do we compare two numbers? Well, we compare them by division. So AB matches up to EF. Well, A to B, the distance there is 4, and EF, the distance there is 3. And I can't simplify that anymore, so this is called a similarity ratio. It exists between this side and this side. Now I'm going to check and see if it exists between the other two sides. So I'm going to check side BC over FG. Well, BC is 8 FG is 6. Well, 8 over 6 is not 4 over 3, except that it really is. We just reduce this. 8 over 6 can both be divided by 2, so we get 4 over 3. So our similarity ratio from rectangle ABCD to rectangle EFGH is 4 over 3. And we can put in between these a similar symbol. And this is called a similarity statement. Just like a congruent statement we had with triangles last unit, this is called a similarity statement. So these rectangles are similar. Now, one of the things that you're going to be asked to do is not just to say that everything is similar. You're going to be given things that may be similar and may not be similar. So, alright, so I'm going to take this triangle. I'll make sure it's nothing special about it, just a triangle. So none of the sides are the same. Don't get all start screaming equilateral at me, or like on the test, everything's equilateral. Not everything's equilateral. I'm going to make another one, and I'm going to twist it around, and then I'm going to manipulate a little bit, just shrink it up a little. So let's label this bad boy. This will be A, B, C, and then this will be D, E, F. And let's say that side AB is 12, and side DE is 8. So BC, and I'm just making up numbers here, is 8, and E to F is 5. AC looks like it's longer than 12, so it'll be 13, so DF would have to be 9. Now we have triangle ABC and triangle DEF, and your job is to decide, are these two triangles similar to each other? Now you saw me make them, right? I made this one, and then I duplicated it and made another one and drug it over here, shrunk it up a little. So I put some numbers on it. The numbers are what matters. It doesn't matter what it looks like or what your eyes tell you. What matters is the math part. So let's start out with some corresponding sides. So AB over DE. All right, AB is 12 and DE is 8. Well, I can simplify that into 4 over 3, right? Because I just used it again up there. So 4 over 3 is the similarity ratio between AB and DE. Well, I got to check more than just those two, so I'm going to check BC. So BC over EF. Over EF. Well, BC is 8 and EF is 5. So I can't simplify that any. So that's the similarity ratio between BC and EF. Now, the problem here is these two things are not equal. So, triangle ABC is not similar to triangle DEF. And I don't even need to check the other side, because if it's not similar on one set of sides, it's not going to be similar anywhere. So that's pretty much it for similarity and polygons. You're going to be doing a lot of these, and the important thing is that you are able to write similarity statements, you are able to write similarity ratios, and you're able to determine when things are not similar. So that's it. Bring any questions you have in tomorrow.